Hello everyone, this is the second grade Enhanced Math Week 13 Division with Remainder Solution video. Example 1. When 9 is divided by 5, the remainder is 1. Because as you see here, the 9 is the dividend, and this is equivalent to the divisor times the quotient, which in this case is 4 times 2. And 4 times 2, this gives us 8, right? But 8, as you can see, is very close to 9, and if we multiply it again, it's going to exceed 9. So therefore, we just leave it as a remainder of 1, because 8 plus 1 is 9. And we can also write this as 9 divided by 4 equals to 2 remainder 1. In example 2, when 27 is divided by 7, the remainder is 6. As you see here, 27 is the dividend, and this is equivalent to 7 times 3. Again, 7 times 3 is 21, and if we multiply it again by 7, that's going to be too much. Therefore, we just leave it as a remainder of 6. We can also write this as 27 divided by 7 equals to 3 remainder 6. Note that the remainder is a whole number that is less than the quotient. Problem 1. Put correct numbers in the blank. The first problem, something divided by 5 equals to 3 remainder 1. For this problem, let's do it simply as we see here that equals to 3. So the whole number 3 is first we multiply 5 by 3 equals to 15. And then we add a 1 because there's a remainder to it as well. And this gives us 16. Second problem, in green this time. Something divided by 6 equals to 2 remainder 3. We multiply 6 and 2 together to get 12, and 12 plus 3 equals to 15. This basically represents that there are 2 copies of 6, and we have remainder 3 that we can't multiply any further, and we just add that to it. So the answer is 15 divided by 6 equals to 2 remainder 3. Next problem, something divided by 3 equals to 5 remainder 2. Again, we multiply 3 by 5. This gives us 15. Remainder 2 plus 2 equals to 17. Next question, something divided by 9 equals to 5 remainder 6. As we see here, 9 times 5 equals to 45, and 45 plus 6 equals to 51. 51. Next problem, something divided by 8 equals to 4 remainder 6. 8 times 4, 32. 32 plus 6 equals to 38. 38 is your answer. And finally, something divided by 7 equals to 9 remainder 4. We multiply 7 times 9 equals to 63. And 63 plus 4 equals to 67. The answer is 67. And that is problem 1. Problem 2. Again, put correct answers and correct numbers in the blank. 16 divided by something equals to 5 and remainder something again, which is a blank. We see here that how many times can 16 go into 5 without doing it much over or less? Well, we quickly see here that 3 times 5 equals to 15, and that's very close to 16 without going over. So therefore, we know that the answer is 3 for the first blank. And then if the answer is 15, because 16 divided by 3 equals to 5, there has to be a remainder. If the closest we can get is 15, it's 15 plus 1, let's write plus 1, equals to 16. So the remainder is 1. Next problem, 30 divided by something equals to 7, remainder something. Well, we can see here that this should be something times 7 equals to 30. And since there has to be a remainder somewhere, we know that the closest we can get is actually just 28, because would just give us 4 times 7 equals to 28. Therefore, we just put the answer 4 in the first blank. And as we can see here, 28 plus 2 remainder equals to 30. So therefore, the remainder is 2. And for the final problem in blue this time, 43 divided by something equals to 8 remainder something. This time we can do something times 8 equals to 40. Because as we see here, 40 is the closest number that we can get to 43. That is still a factor of 8. We can just do 5 times 8 equals to 40, and we put 5 in the first blank. And then, since 40 is very close, we just see how much we can add until we get 43, and we just get 3 equals to 43. So the remainder is 3. Problem 3. Jack had 40 candies. He kept several candies for himself and gave the rest to his 6 friends. If each friend received the same number of candies, how many candies could each friend get at most? The starting information we are given is that Jack had 40 candies. All right, Jack had 40 candies, and he had several candies for himself and gave the rest to his 6 friends. If each friend received the same number of candies, how much candies could each friend get at most? All right, let's set this question up. Basically, we have 6 friends, and we have to see the next least number that is less than 40, since it says that he kept several candies for himself. The next number below 40 that is still a factor of 6, we have to use that number. Because, as we see here, the same number times the 6 friends has to be some number which is less than 40, and we quickly get that answer is just 36. Because, as we see here, 36, the remainder, if added to 40, is 4, which is not enough to make another batch of 6 candies, which means that 6 times 6 equals to 36. Each friend could get 6 candies. And this means that Jack kept only 4 to himself. Problem 4. If today is Monday, what day will it be after 30 days? Okay, so if we know that every week is a 7-day cycle, this means that we just divide 7 by 30. And we know that if we divide it, that answer will have a remainder, but for the full numbers, it will still be Monday. 30 divided by 7 equals to, at most, 28, because 7 times 4 is 28, and that's the most we can get to 30 without overlapping. And as we know, this is still Monday, because it's still a 7-day cycle, weekly cycle, and we'll return to Monday. But we still have 2 days left over, so let's add another day, which gives us Tuesday, and add another day to get us 30, and this will be Wednesday. So the answer is it will be Wednesday after 30 days. And that is problem 4. Problem 5. According to the following pattern, what is the letter on the 50th position? As we are given a pattern of A, B, C, D, E, F, A, B, C, D, E, F, A, B, C, D, E, F, and so on. As we see here, A, B, C, D, E, F consists of 6 letters. So that means that if we are asking for the 50th position, if we divide it by 6, we will get an answer and remainder of something as well. Whatever answer is in the first blank, that will still be ending at the F, since that is 6 letters, it's just repeating itself. And we quickly get that 6 times 8 is 48, and that's the closest we can get to 50 without overlapping or without going over. So we write 8 in the first column, and as we see, there are 2 letters left over, and we quickly get that if we ended on F, we just go 2 spots over, which is B. So remainder 2, the answer is B. Problem 6. Alice had n toys. If she counted them by 3, there were 2 left. If she counted them by 5, there were 4 left. What was the least possible value of n? So for this problem, here we are basically looking for the smallest whole number that has the remainder 2 when divided by 3 and has the remainder 4 when divided by 5. So let's first list out numbers that have remainder 4 when divided by 5. For example, let's do 4, 9, 14, 19, 24, 29, so on. And it is easy to see that 14 is the first one that has remainder 2 when divided by 3. So therefore, the answer is 14. Problem 7. If this path is to continue in the same pattern, as you see here that the pattern is right here, I'm going to highlight it in red, that's the pattern, then which sequence of arrow goes from point 31 to 33? All right, for this problem, it's quite a bit tricky, but we can still figure it out. As we see here, the pattern is used up of 3 line segments and 4 numbers. Let me highlight the first one in green. As you can see here, it goes on the right first, and then goes on top, and then goes to the right again. That is the pattern for each bracket. And the bracket coordinates are 0, 1, 2, 3. If it were to go from point 31 to 33, we have to see how much 4 numbers that can be divided into. because as you can see, every set of this pattern includes 4 coordinates. We see here that if we are ending on, let's see, 33, because it says from which sequence of arrows goes to point 33, 33 divided by 4, which is the number of numbers in each pattern. 33, this quickly gives us 8 and remainder 1. And we have to go backwards 1 because we see here that it goes from point 31 to 33, and 33 is the top number. So we have to go back 1, which is, let's see, if this is 8, remainder 1. Let me draw this out. Let me draw this out in red. All right. And since the remainder is 1, we see here that point 33 is the one located in the yellow because that starts a brand new bracket. And it says from which a sequence of arrows goes from point 31 to point 33. We just go back to, highlighted in blue this time, 33, 32, and 31. So since 31 is at the end of the cycle, which is 28, 29, 30, 31, and 33 is on the second position of the next cycle, which is 32, 33, 34, and 35, we quickly get that 28, which is the first one on the sequence, which is just on the bottom left-hand corner. 29 goes right, 30, of course, goes on the top, 31 goes on the right-hand top. So that is a sequence, right? And then the bottom one starts all over again, 32 and 33. And since it's asking us what sequence of arrows goes from 31 to 33, we just highlight this. And let's see, this one is, of course, just this figure, right? And we have to see which one it matches closest to, and of course, it is C. So the answer is C for problem 7. Problem 8. There are 43 green, red, and yellow beads on a rope. Those beads are placed accordingly to the following pattern: red, red, green, green, yellow, red, red, green, green, yellow, red, red, green, and so on. How many green beads are on the rope? We have to look for the pattern in this, which is just quickly 5 beads in a pattern, 2 red, 2 green, and 1 yellow. And then this is fairly easy. There are 43 beads in total, divided by 5 in each sequence. This quickly gives us 8 with remainder 3, because 5 times 8 is 40, and we have 3 left over to get us to 43. So we don't have to care about the 8 really, because as there are 8 patterns, 8 times 2, 2 green in each pattern, that just gives us 16 green beads. And the remainder 3, so we start from the beginning again and bounce 3. 1, 1, 2, and 3. And as you can see here, once we landed on 3, we have a green bead, so we need to add another green bead to the 16 green that we already have, and this gives us 17 beads in green. And the answer is 17 for problem 8.